Okay, so today we're going deep, really deep, into something pretty ambitious.
Ambitious is an understatement. Maybe.
Yeah,
Gravity manipulation.
that's right. Gravity
The
manipulation.
idea of actually being able to control, to harness, maybe even defy gravity.
Exactly. So based on some really fascinating material we've been looking at.
Some really out there stuff.
Yeah, some wild stuff.
We're asking that big question.
Yeah, the really big one. Could we ever actually get a grip?
Get our hands on.
Yeah, get our hands on the controls, so to speak, of this most fundamental force.
I mean, it's the force that shapes the entire universe, right?
It's the unseen ruler, literally, that keeps our feet on the ground.
Keeps us from floating off into space. Exactly.
It dictates how planets move, how stars are born.
Keeps the whole cosmic dance going, you know what I mean?
Yeah, but here's the thing, and it's kind of mind-blowing when you think about it.
Go on to one.
It's actually the weakest of the fundamental forces.
Yeah, and that's always kind of tripped me up, you know?
It is pretty wild.
You've got this force that governs the entire universe, galaxies, everything, but then you take a tiny little fridge magnet, right?
Yeah, like the ones holding up your kid's artwork.
Exactly, and that little thing can defy the entire Earth's gravity.
Just like that.
Just like that, makes you think.
It does make you think. And throughout history, humans have always dreamt of breaking free. Right?
Absolutely, overcoming gravity, flying.
Yeah.
It's this primal urge, isn't it?
Totally. It's woven into our myths, our stories, everything.
So now we're asking
That what if question.
the really juicy one.
What if we could control gravity?
Just imagine the possibilities.
I mean, space travel, forget rockets, forget fuel.
You're zipping across galaxies.
Yeah, like it's a Sunday drive.
And then think about the military applications.
Oh, it's a whole other ball game.
A whole new kind of warfare.
Yeah.
And not necessarily in a good way.
Exactly. And our everyday lives would be unrecognizable.
Floating cities, personal anti-grav devices, who knows?
Okay, so that's where we're headed today.
Buckle up.
We're going to take this Sci-Blowing podcast draft you found.
It's a wild ride.
It is.
A total deep dive into how we understand gravity now, how it's evolved.
And most importantly, this quest, this sometimes fictional quest, to actually manipulate it.
To bend it to our will.
So let's start at the beginning with gravity itself, the unseen ruler, as they call it.
Okay, back to basics.
It's the force that, on the grandest scale, holds the universe together.
Keeps the planet spinning around the sun.
Make sure black holes don't just wander off.
Exactly. But then it also, and this is where it gets weird.
Yeah, this is the paradox.
It's the weakest of the four fundamental forces.
Yeah, way weaker than the strong force holding atoms together.
Or the electromagnetic force.
Light, electricity, magnetism, all that.
Right. And the source actually points this out. We can block those forces.
Relatively easily, yeah.
Build a wall, use a shield, but gravity,
We're stuck with it.
like it or not, it's always there.
So how did we even get to this point? How did we come to understand this weird, powerful, yet weak force?
Well, it starts with the OG, right?
Isaac Newton, apple falling from the tree, the whole deal.
Exactly. He gave us the basics.
Gravity is a force of attraction between any two objects with mass.
Simple, elegant, explains why planets orbit, why we stick to the Earth.
A massive breakthrough.
Huge. But it didn't quite explain the how, you know.
Like, how does this attraction actually work?
That's a million-dollar question, and that's where Einstein comes in.
With the theory of general relativity, a total game changer.
Yeah, this is where it gets really mind-bending.
Because Einstein didn't see gravity as a force pulling things together.
Not at all. He saw it as a curvature.
A curvature in the fabric of space-time itself.
Whoa.
Yeah, whoa, caused by mass and energy.
So think of it like this.
Okay, I'm listening.
You've got this big rubber sheet, right, stretched out tight.
Okay, got it.
You plop a bowling ball in the middle.
Creates a dip, right?
Exactly. Now roll a marble across the sheet.
It's going to curve towards the bowling ball.
Because the bowling ball warped the sheet, created that dip.
So the bowling ball is like the Earth.
Yeah, and the marble is like us.
So instead of the Earth pulling us down...
We're just following the curve of space-time that the Earth creates.
Okay, my brain is officially melting.
I know, right? It's crazy.
But it's also kind of beautiful.
It is. It's like this elegant cosmic dance.
So we've gone from Newton's what to Einstein's why.
And
Now we're at the how do we control it stage.
the gravitational freedom stage, as our source puts it.
I love that phrase, gravitational freedom.
It's so evocative, isn't it?
It really captures this desire to not just understand gravity, but to actually master it.
To break free from its constraints.
Okay, so let's jump to the present day. What kind of research is actually happening right now in this field?
So there are a few key examples that the source highlights, some more controversial than others.
Some definitely bordering on science fiction, right?
Yeah, let's start with NASA's Breakthrough Propulsion Physics Project, BPP.
This was what, back in the late 90s, early 2000s?
Yeah, it was this really ambitious program. Unfortunately, it got discontinued
But the idea was
to explore some really out there propulsion concepts.
things that could revolutionize space travel.
Yeah, stuff that could potentially, just potentially, manipulate gravity or inertia.
Right, because traditional rocket propulsion.
Yeah, it's got limits. It's slow. It's inefficient.
Especially if we're talking about interstellar travel.
You're talking about generations on a spaceship. It's just not practical.
So they were looking for something completely different.
Something that could tap into these fundamental forces.
But then there's this other one. It's way more controversial.
Oh, yeah. The Podkletnov experiment.
This is the spinning superconductor one, right?
That's the one. From 1992, this Russian scientist, Podkletnov, claimed he could reduce the weight of objects.
Using a spinning disk made of superconducting material.
It sounds like something out of a movie, I know.
It does, so why are we even talking about it?
Because even though the results were never replicated consistently,
Okay, if your scientists couldn't reproduce it.
right, it raised this tantalizing possibility.
That superconductivity could somehow interact with gravity.
Two completely different areas of physics, but maybe, just maybe, there's a connection.
It sparked a lot of debate.
Oh yeah, and a lot of research, even though most of it didn't really pan out.
It kept the idea alive, though, that there's something there to be explored.
Even if it's just a tiny glimmer.
Okay, and then there's the M drive.
Ah, yes, the M drive, the impossible engine.
The one that supposedly generates thrust without expelling any propellant.
It violates, or at least appears to violate, one of the most fundamental laws of physics.
Conservation of momentum.
You can't get something for nothing, right?
That's the rule, but
But multiple teams, independent researchers.
have reported measuring some thrust, even if it's tiny.
So what's going on there?
Is it experimental error? Is it something we haven't accounted for?
Or did a glimpse of something truly new?
Something that could change everything.
It's a mystery, but a really intriguing one.
So we've got these kind of fringe experiments.
Pushing the boundaries, challenging our assumptions.
But then the source also brings up something much more established.
The detection of gravitational waves by LIGO.
This was huge.
Monumental. A Nobel Prize-winning discovery.
Yeah, they actually measured these ripples in space-time.
Predicted by Einstein, by the way.
100 years ago.
And caused by these incredible massive events like black holes colliding.
Now, it doesn't directly tell us how to manipulate gravity.
But it gives us this incredible new tool to study it.
And it confirms, once again, that Einstein was right.
Which, let's face it, he usually was.
So we've got this spectrum of research, from the fringe to the firmly established.
And somewhere in between, there's this theoretical concept.
This idea proposed by Dr. Ning Li,
Yeah, she put forward this idea of generating localized gravitational fields.
using high-frequency rotating ions, charged particles, basically.
And the theory is, if you can control these particles in just the right way,
You could create this warping of space-time.
a localized gravitational effect.
And it's purely theoretical.
It's highly speculative, really.
But it's the kind of idea that sparks the imagination.
Makes you wonder, what if?
Okay, so it sounds like we're not quite there yet with real-world gravity manipulation.
Not quite. But our source then takes a really fun turn
It leaps into the world of science fiction,
with Project Aether, a fictional scenario.
but one that explores the potential of this technology.
What if we could actually build a gravity engine?
So let's dive into this, into Project Aether.
Okay, so picture this. It's the year 2133.
The future, sleek spaceships, all that.
A company called Singularity Systems claims they've cracked the code.
They've developed this prototype vehicle, the Aegis.
And it supposedly uses this fusion of quantum superconduction and space-time oscillation.
Okay, hold on. Those are some big words.
I know, but stick with me.
Okay, I'm trying.
Quantum superconduction basically is when electricity flows with absolutely no resistance.
Like a superhighway for electrons.
Exactly, and this leads to all sorts of weird quantum effects.
And space-time oscillation.
Think of it like creating controlled ripples in the fabric of space-time.
Like throwing a pebble in a pond.
Kind of, but instead of water, it's the fabric of reality.
Okay, now my brain is really melting.
I know, it's wild, but the idea is if you can generate the right kind of oscillations,
You can counteract gravity?
Or even create your own localized gravitational fields.
And that's what the Aegis supposedly does.
It can hover silently.
No noisy engines, no propellers.
It can accelerate to Mach 30.
30 times the speed of sound.
Without any
There's
G-forces.
no crushing sensation. You just smoothly zoom.
And it can change direction instantly.
Like a hummingbird flitting around.
And it can even glide through space without any fuel.
No need for clunky rockets.
Just pure, elegant, gravity-defying motion.
It's like something out of a dream.
It is. It's the ultimate expression of gravitational freedom.
The source has this great line about it.
Oh yeah, I love this one.
It defies what we know. Or maybe it finally uses what we don't.
Yeah. It hints at the idea that there are these hidden secrets of the universe.
These laws of physics we haven't even discovered yet.
And maybe, just maybe, this fictional technology has tapped into them.
Okay, so let's say, for the sake of argument, that this is possible.
Let's play pretend.
What would the implications be?
Oh boy, where do we even begin?
The source calls this section military, migration, or mayhem.
It's a good title because it covers the whole spectrum.
Yeah, let's start with the military.
I mean, just imagine one Aegis-class vehicle could wipe out entire air forces.
No more fighter jets, no more missiles, no more satellites.
All obsolete overnight.
It'd be a complete shift in the balance of power.
The world would be thrown into chaos.
And then the source throws in this curveball.
Oh yeah, the rogue group.
They steal a prototype and disappear into deep space.
Gone. No one knows where they went.
And then months later,
Strange signals detected near Saturn.
what are they doing out there?
Are they terraforming moons?
Building a secret empire?
Creating wormhole?
The possibilities are endless and terrifying. It really highlights the double-edged nature of this technology.
It could be used for good to solve Earth's problems.
Or it could be used for selfish gain, for destruction.
It's a choice we, as a species, would have to make.
And it's not just about Earth, it's about our place in the universe.
Do we use this power to explore, to expand, to colonize?
Or do we focus on our own planet, on fixing what we've broken?
That's a profound question.
Okay, so let's move beyond the practical, the geopolitical, into the philosophical.
Yeah, the big questions.
The source calls this redefining physics and ourselves.
I mean, if we can control gravity,
What does that say about us?
about our understanding of the universe,
About our potential
it's like, are we approaching this type by civilization level?
on the Kardashev scale?
Yeah.
Yeah, where we can harness all of our planet's energy.
And then there's this idea, this dream, really,
Of unified field theory.
a holy grail of physics.
A single theory that explains all the forces of nature.
And maybe, just maybe,
Gravity is the key.
if we can unlock its secrets.
We can unlock everything.
But then on a more personal level,
Yeah, what happens to us, to our bodies, to our minds?
if we're no longer bound by gravity,
Do we evolve differently?
do we even recognize ourselves anymore?
It's like we're on the verge of something truly transformative.
The source calls it the beginning of gravity hacking.
I love that, gravity hacking.
It's like we're not just passively observing the universe anymore,
We're actively engaging with it.
rewriting the rules, maybe even breaking them.
So that brings us to you, dear listener.
And some big questions to ponder.
Our source poses these in their discussion segment.
And they're designed to really get you thinking.
So the first one, it's a doozy.
Would you, personally, be willing to ride in a gravity engine-powered craft?
Knowing that it seems to defy all known laws of physics,
Would you trust your life to the unknown?
that's a tough one. It really makes you examine your own beliefs.
About science, about technology, about risk.
And then the second question,
Should gravity manipulation be open source?
should anyone be able to access this knowledge?
Or should it be controlled, restricted, for the sake of safety?
It's a classic ethical dilemma.
Freedom versus security, progress versus caution.
There's no easy answer. And finally, the really big one, the mind-blowing one.
If we can defy gravity,
What other limits can we break?
what other impossible things might become possible?
It really makes you wonder about the true nature of reality.
And our place within it.
So those are the questions, dear listener.
Take them with you. Wrestle with them.
Because the implications of gravity manipulation,
Are truly profound.
they touch everything.
Our science, our technology, our philosophy,
Even our very humanity.
and as our source so beautifully concludes,
When we master gravity,
it's not just about floating
it's about ascending.
to a whole new level of understanding,
And maybe, just maybe,
to a whole new way of being.
it's a journey worth taking, even if it's just a thought experiment for now.
Absolutely, it's a journey into the heart of what's possible.
And that's what makes it so exciting.
And maybe just a little bit terrifying.
But definitely worth exploring.
100%.
So keep those questions in mind. And until next time,
Keep looking up
keep wondering,
and keep pushing the boundaries of what we think we know.
because who knows what we might discover.
That's the beauty of it all.
That's the adventure.